Hello there, I'm Thomas. This is German American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an Lszh localizer landing. So right now I'm in the cockpit of the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments and displays and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display. The displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude of the outside atmosphere, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, and the target altitude selected from the autopilot flight director system panel. The vertical rate of climb and descent of the aircraft in 10,000 feet per minute, or the signals so that the chronometric angles in decrease can climb and descend. Also, we have the artificial horizon with the attitude indicator, the pitch ladder degrees, and the bank angle in degrees. We have also the Lszh localizer, the instrument landing system that receives from the onboard antennas of the aircraft the radio frequencies transmitted from the runways we use for takeoff and for landing, the antennas of the threshold of the runways. So we have a unique Lszh localizer for each runway frequency, unique frequency and magnetic north pole heading. So we have to tune for each airport separate Lszh localizer frequency. You can see the Lszh localizer frequency. So I will show you how we're gonna tune it either manually or automatically. And we have the display of the horizontal localizer that aligns us with the magnetic north pole heading of the runway we use for takeoff and for landing, and the vertical glide slope for approach and landing for the angle of approach. So we have also the Lszh localizer crossbars. We have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the auto throttle. Later on vertical navigation mode, we have also the HSI, the horizontal situation indicator, that displays the magnetic, that displays the horizontal situation indicator, that displays the heading and track, and also the integrated display of the flight plan. We have also the navigation display, that displays the GPS inertial reference position of the aircraft, its coordinate position, latitude and longitude. We can align with the flight management computer and the inertial reference system panel and the overhead panel. So I will show you later how to do that. We have also the display of the magnetic north pole and the geographic north pole, and the magnetic variation depending on where they are in the world. We have the terrain and weather reflections from the weather radar. You can see the terrain elevation displayed with red, green, and also amber or yellow indication, and also the blue for the lakes, the rivers, and the sea. You can see the airports around us, and also our own airport displayed with a 4-letter car name with blue color. Also, we can see also the airport where we allocated the runways we're gonna use for takeoff and for landing, the runway heading and its length, and also we can see the taxiways we're gonna use for taxiing from the GPS display. Also, you can see the navigation aids, the nav aids, which are the world stations, ADFs, and DBs. Also the waypoints, which are horizontal, vertical navigation fixes and altitude and airspeed constraints. We're gonna select some from the flight management computer, some waypoints, and we're gonna be having to fly through as we're gonna be flying using the flight management computer. We're gonna make a flight plan or a flight path or a route. So it's gonna be connected with waypoints and a purple or magenta line. You're gonna see it displayed in the navigation display and in the HSI also. So you can see here I'm gonna start showing you all the instruments, the autopilot flight director system panel, the engine certification, flight management computer. So we're gonna make a complete flight in the end part of the video after showing you all the engines and all the systems of the aircraft. And make an engine start demonstration and set up the flight management computer. In the end part of the video I will show you a complete flight from takeoff, climb, cruise, descent, approach, and landing. So stay with me until the end part of the video to see the complete flight, the full manual flight. I'm gonna show you also in the navigation display. You can see how the aircraft fly around our own aircraft using the transponder, the ADC and ADC transmitter receiver that transmits our frequency to other aircraft and the air traffic control and receives from other aircraft. You can make calculations using its computer for the other aircraft distance and location where they are located with respect to our aircraft they're bearing. Also the altitude difference between our aircraft and the other aircraft. You can calculate how many hundreds of thousands feet the other aircraft are above or below us, whether they climb or descend with respect to our aircraft. Also you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning if we have an incoming collision with another aircraft in the air. Using the TICA system, the traffic collision advisory system, so we'll have to make an avoidance maneuver in the air and also in the ground. It displays for the taxiways and the runways. So this is the TICA system, you will see later in the transporter. I'm gonna show you also, you can see the diamond shape of the other aircraft in the navigation display. So I'm gonna show you also other instruments and functions of the Boeing 787-900Z aircraft. I'm gonna show you also the flight controls. You can see I'm having here the side stick that I use to control the flight controls of the aircraft in the air or in the ground where we are in takeoff and landing. You can use the elevator for climb and descent, the pizza axis of the aircraft. So it's in the side stick. You can see I have the side stick of the Airbus to control the yoke of the Boeing aircraft, so we can climb, we can descend, we can make also turns right or left using the control wheel in the Boeing aircraft instead of the side stick. So you have the control column for climb and descent is the side stick back and forth in the Airbus. Also the rudder pedals, you can make the vertical tail, the rudder of the aircraft, left and right directional control, and also we have the nose wheel steering, which is interconnected with the rudder pedals over here, the tiller, so we can control the aircraft. I will show you also the outside view of the aircraft for all these indications. So I'm gonna show you how to use the flight controls. So I will talk to you about the aeronautical and aerospace engineering, about the Newton's physics, and also about some things we need to know about flying the aircraft, the aerodynamics of the aircraft, Newton's physics and Bernoulli theory of fluids we need for the air transport pilot license and the commercial pilot license. So also the outside view of the aircraft and how to control its flight controls in flight. So you can see here we have the outside view of the aircraft of the Boeing 787. You can see the surface area of the wings hold the weight of the aircraft when we fly. Also we have the thrust vector, the Z plus from the engines. You can see we have the Z engines, we have the high pressure and low pressure compressor and turbine, and also the Z blast here from the exhaust of the cones from the nozzles. Also we have the front fans over here and the combustion zappers. So you have the thrust vectors to move the aircraft forward from the engines. You have the mean aerodynamic chord position over here, the Mach, which is 23% of the mean aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the center of pressure is moving back and forth in the top surface of the wings when we fly. Also is the position where the airflow becomes detached from the top surface of the wings. When we fly in the aircraft, the wings stall, so we need to monitor the stall inside the aircraft. So you can see here we have the primary flight display. You can see we have the airspeed tape over here. We have the airspeed indicated, the airspeed selected from the autopilot flight directorship, system panel, barometric altitude. I'll talk here about this a while. So we have the when we fly in the airspeed, and you can see also the stall speed displayed with an amber and red indication just below the airspeed. You need to pay attention because we make it's what is actually makes the aircraft fall off from the sky is the stall of the wings. So we need to apply more thrust from the engines when we reach the stall, and also push down the elevator to decrease the angle of attack of the aircraft as we fly. So we have over here, as I'm telling you, the main aerodynamic chord position. You can see we have the left and the right wing, where is also the fuel tank, the left and the right wing fuel tank, the center tank of the aircraft. So we have 30% right now in the left and the right wing, and 10% the center is where the center of gravity is located. It transverses down here. So the center of gravity of the aircraft is where the yawing axis is located. So we can make yawing turns left and right using the rudder pedals, the yawing axis of the aircraft. So this is the rudder. You can see where the rudder pedals are. Is this functional control of the rudder pedals. You can make left and right turns using the vertical stabilizer of the rudder. So I have it in the side stick like this, in the vertical axis of control of the side stick, the rudder pedals. So also you have the nose wheel steering with the rudder pedals or the tiller, so you can deflect over here the nose wheel of the aircraft to make left and right turns, again alongside with the rudder. So it's control 76 degrees left and right turns from 0 knots all the way up to 45 knots. It decreases then because at 45 knots we have at 45 nautical miles per hour in takeoff or in landing we have the rudder aerodynamically effective, and above so it decreases to 7.6 degrees left and right the nose wheel steering over here of the aircraft above this airspeed 45 knots. Then as we increase the airspeed for takeoff or we are in landing above 80 knots, the nose wheel steering is controlled to 0 deflection, is locked, and it cannot move left and right either direction. So we have only the rudder to control the steering of the aircraft in the runway above 80 nautical miles or about 140 kilometers an hour. We have only the rudder. Below 140 kilometers an hour we have also the nose wheel steering, and it decreases as we decrease the airspeed. So this is the inverse when you land. So we have here, you can see we have the rudder pedals, so this is the yawing axis, and the nose wheel steering, they're connected. So we have also over here we have the lateral axis from wingtip to wingtip, another axis which is the pitch axis of control. You can control the elevator of the aircraft over here for climb and for descent like this, as you can see. So this way you climb, you use the side stick in the Airbus aircraft for climb and descent, or the yoke in the Boeing 787 for instance. So you climb and you descend like this. As you can see, climb and descend, the control column, the yoke of the Boeing 787. All the side stick in the Airbus is for climb descent, the pitch axis, so you can climb, you can descend like this. So climb descend like this. And also we have one more axis here from nose wheel to the tail of the aircraft is the longitudinal axis that transverses all the other axes of the flight control. So this is left and right side stick in the Airbus is the control column, left and right over here, as you can see, control column. Left and right in the Boeing aircraft, this is side stick. Left and right is the ailerons and the spoilers, or longitudinal axis of control in flight. So you can make left and right turns like this. In the air using the ailerons, spoilers and flaperons of the Boeing, or only the ailerons and spoilers in the Airbus aircraft. So you can see the flight controls moving in its left and right wing to make left and right turns using the aerodynamic forces, increase and decrease differential lift between the left and the right wing to make the roll in the air. So this is the roll control, longitudinal axis, the pitch axis, climb descent, also in the rudder axis, left and right turn. So we have all flight controls like this. So maybe have better view like this. I don't know. I'm controlling the flight controls. Maybe the screen is not looking so good, but I'm trying so. Yeah, here is better view of the screen. So you can see the turn of the rudder, the yawing axis and the nose wheel, ailerons and spoilers, side stick left and right, or control wheel in the Boeing, side stick in the Airbus, and side stick and yoke up and down in Boeing and Airbus. It's the elevator for climb and descent. So we have all flight controls like this. You can see side stick, all flight controls are side stick deflection is proportional to the yoke and rudder pedals deflection and control wheel. Also you can see in the Boeing aircraft both the captain and the first officer are interconnected. Both sides move together simultaneously all time unless you have a failure of the system of the flight controls, which will need to be overridden. You use override force from either left and right side. So in the Airbus you have the side stick priority. You can use either side stick instead. So we have a couple more things to see about the flight controls of the aircraft. Of the Boeing 787, I will show you one more view of the 787 flight controls, and then I will show you the rest of the system. So I will show you again the outside view of the flight controls of the Boeing 787. So we need to take a closer look at the flight controls of the Boeing 787. I hope you like it. Also I'm gonna show you the horizontal stabilizer trim, the elevator trim of the aircraft of the Boeing 787, the flaps and the slats, the speed brakes, the thrust levers control, have all controls over here in the side stick. So you can see here one more view of the Boeing 787 like this. So maybe you have a better view like this. So we can climb and we can descend, make turns to the right and turns to the left. So we climb like this. You can see the side stick deflection is proportional to the yoke deflection. Hope you like. Have the horizontal trim stabilizer over here. Hope you like the view of the side stick that I'm using. My computer also, the whole setting over here. Also you can see the thrust levers over here. So you can move the thrust levers back and forth like this. You can increase and decrease the airspeed of the aircraft when we fly, and the pitch attitude also. You can see the thrust levers moving forward and up. See the engines reaction. So this is the thrust control. Like this, we move the engines forward and aft. So hope you like the flight controls of the Boeing 787. Also make turns left and right. Maybe better view right now, much better. Screen view also. Also the outside again with this side view. Yeah, it's better. Video more clear. So you can see we can climb and we can descend. We can make turns right or left like this. So again, left and right turns over here. So we have full flight controls of the aircraft of the Boeing 787. You can see how gorgeous aircraft is. So climb, descend, make turns to the right, make turns to the left. So I'm gonna show you now a bit of the rest of the flight controls and the systems of the Boeing 787. So this is enough for the flight control lesson. I will show you now the horizontal trim stabilizer, the thrust levers, the engine indication, the displays of the aircraft of the Boeing 787, and the autopilot flight director system panel. Also you're gonna see the overhead panel. So I'm gonna start now maybe with the horizontal trim stabilizer and the displays. So you can see here we have which is part of the flight controls. You can see we have the horizontal trim stabilizer over here. So we have the control of the horizontal trim stabilizer, which controls the horizontal tail elevator, nose up and nose down. So you trim the elevator this way. You control the elevator. You can see the side stick that I'm having here to control the elevator up and down like this. Also you have the trim of the elevator surface as you fly. So you can trim like this. You use the elevator trim, which pitches the nose of the aircraft as you fly up, and this way you pitch the nose of the aircraft down. You trim the elevator down. So you can see the elevator position degrees over here in the display, how many degrees you have it. So you can see nose down and nose up over here. Stabilizer trim 4.25 degrees. We have also the rudder trim over here. So this is how many degrees you can see. This is the normal channel of the flight controls computers. You can see also the flap speeds, some other information here. So we have the elevator trim, left click down, right click over here up. So you can read the elevator trim, left click down, right click up over here. So this is very important for balancing the aircraft in the air. You have the normal and the alternate channel of the flight controls computers over here for the horizontal trim stabilizer. So you trim up this way, you trim down, and you pitch the nose up and you pitch the nose down. You have also the autopilot disengage switch and the head up declarer, a couple more switches. So this is under the normal flight control computers channel. You have also the flight control computers over here. So we have the primary flight control computers in the normal, alternate and direct mode, as you can see. So we have also the automatic trim of the aircraft. So the auto trim is also controlled by the autopilot flight director system panel, the auto throttle. So we have the automatic trimming instead of the manual. We have also the alternate channel of the flight control computers over here. So you can see we have the pitch alternate over here. This way you trim the elevator up, and this way you trim the elevator down like this. So you pitch the nose up and you pitch the nose down instead of having a trim wheel. So you can see again elevator trim, left click down, right click up. You can see also we have the parking brakes here set, and we have also the stabilizer cutoff alternate. You have the normal, the alternate. This is the cutoff switch, as you can see, the guarded switch. So you can see. So if we have a failure of the flight controls system, of the primary flight control computers degradation, because we have some system like the hydraulics, you can see engine driving left and right engine, and electric C1 and C2, we have a failure that affects the flight controls of the aircraft. We're gonna lose the automatic trim over here, the auto trim system. So this is for Boeing 737, 747, 757, 767, and Boeing 777 and Boeing 787. You come down here, open this red guarded switches and disconnect either left and right or together, and you use only the alternate pitch trim. You lose the auto trim function from the aircraft, and you have the alternate manual trim channel like this, as you can see. And also you have the manual trim switch over here all the time, so you can trim the elevator up and down like this as you fly the aircraft. So this is all flight controls. Hope you like it. I'm gonna show you also the rest of the systems. So we have a couple more systems to see. So this was the elevator trim function, as you can see, automatic trimming also. So this is fly-by-wire aircraft, the Boeing 787. It has the flight control computers to control the flight control surfaces, deflection in the air, to limit and control the maneuvers the aircraft make in terms of G loads and acceleration of the gravity loads in terms like 2.8 Gs in left and right turns, so 67 degrees in the Airbus, or 30 degrees or 1.5 G incline, and minus 15 degrees or minus half G in descent. This is the Airbus limit. I'm not sure about the Boeing limits, but it must be similar because this is how the fly-by-wire acts. Also to keep other balance in flight. And you have also the auto trim function. So I'll show you the auto trim, what it's doing for the Airbus, for the Boeing actually. You can disconnect the automatic trim and use on the manual. If you have failure, you do that. So I will show you also a couple more systems of the aircraft. You can see the displays, the autopilot flight director system panel over here, the flight management computer. So you can see here we have also the fuel control of the left and right engine, the thrust levers, left and right engine thrust levers over here, and the thrust reverse over here. We use the thrust reverse, the flaps and the speed brakes, the fuel control over here. You can turn off the engine, the fire extinguisher, left and right engine, pull out and switch, the transporter, and the rudder trim over here. You can see also the radios, navigation radios, high frequency, VHF, and satellite, also ground proximity weather radar, transporter. Also you can set some navigation radios. Also we have here, I will start showing the displays of the aircraft. So you can see here we have the primary flight display. You can see the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the barometric altitude above the sea level, the vertical rate of climb center of the aircraft in tens, hundreds of thousands of feet per minute. You can see the flight director crossbars. Also the Lszh localizer and the autopilot are quite similar crossbars. You can see the radio altitude above the ground level right now is -2 feet, but it can display like 2,500 feet above the ground when we fly. The vertical distance from the ground below you. So you can see also this needles moves up when we climb like 500, 1000, 1500, 2000, 3000, 6000 feet per minute for climb or for descent. So this is what it tells you actually what the aircraft climbs in the sun. You see this needle moving up and down, and the altitude you see increase or decrease, barometric altitude. Also we have the barometric pressure here, 29.92 inches of mercury for this barometric altitude setting. Over here on the radio altitude minimums, so we set the barometric altitude in the bar set here inches of mercury or hectopascals. Right now it's 29.92 inches of mercury or 1013 hectopascals. So we have also minimums for approach and landing, plan, rates. Over here some other displays with the radar, traffic, terrain on the display. This is about the navigation. Also display the plan or map mode. Over here you can see the terrain map with the airports and the elevation of the terrain, red, green, yellow. You can see 4,900 terrain. The elevation with red and amber is 1,600. Also when you fly, you see the aircraft symbol, you climb higher above the terrain surface below you, like some mountains. Also couple more things. You can see accept, cancel, reject some warnings from the system. You can see also system display, CDU info, checklist, communication, navigation display, ACAS, left and right, multifunction display, expand, engine indications. So right now we have the engines indication. I will talk to you about it in 1 minute. So you can control this display also. We're gonna have the systems of the overhead panel, like the electric, hydraulic, fuel system, pressurization, bleeder for air conditioning displayed here, flight controls in the display later. Also the checklist. So we have keep talking about this system. You can see the artificial horizon, the pitch ladder, it decrease here, and the bank angle decrease, vertical rate of climb descent, barometric altitude above the sea level with this barometric pressure. So you see 2.5 over here, 5, 7.5, 10, 12.5, 15, 17.5 to decrease for pitch out or pitch down. And the bank roll, the bank turns over here in the air. You can see like 5, 10, 20, 30, 45 degrees in turns left and right degrees. So you have also the airspeed. We have the flight mode denunciator here, takeoff ground mode for the thrust arm. When we arm the thrust levers, this is what shows the flight mode denunciator, what the autopilot setting is, and also the auto throttle or thrust levers position, command engine thrust. You see them on here in the flight mode denunciator. We have also the HSI over here. You can see the VOR. So we have the VOR and ADFs here. So you can see ADF left and right over here. Select. And also the heading we have selected. So we have the selected values, 200 nautical miles per hour from the autopilot flight director system panel displayed in this box with purple or magenta color, and 10,000 feet, and the heading 360 degrees. So you can see here in the autopilot flight director system panel we have the same values selected. So we can see we have 200 nautical miles per hour, the airspeed selected, airspeed guidance of the aircraft. So we have also you can see set the airspeed different indicator nautical miles per hour, Mach speed. We have the autopilot engage, disengage, LNAV and VNAV, later navigation, vertical navigation, flight level change, climb continuous, auto throttle, flight director, on and off heading, bank angle, limit and heading, vertical rate of climb descent, of flight path angle, and the altitude set. Also for localizer and approach for autoland, autopilot engage, disengage. You see 200 knots, 360, 10,000 is displayed both sides over here of the primary flight display. Same setting for the airspeed and the heading. So you see again 200 knots. I'm gonna change that later. 200 knots and 10,000. Gonna use more value in the heading. 360 degrees. Also you can see the altitude 10,000 feet is selected here and displayed with this needle, with this line, this dotted line here. You can see the aircraft symbol. We're gonna be flying, gonna be trying to level off. You can see the altitude over here in thousands of feet. Now it's selected 10,000. Like in the autopilot we have 16. You can change the range, move to different altitudes. So all these displays are displayed using the air data computer over here. You can see heading reference, IRS, left and right. You can use to align the aircraft. We have the laser gyroscopes. We have the pitot static and pitot dynamic, pitot tubes, calculation sensors for the airspeed and the altitude, barometric altitude, and also rate of climb descent. Also the attitude of the aircraft, the attitude indicator, the magnetic north pole, geographic north pole, magnetic variation, and also the GPS receivers are controlled from the air data computer, sensors and receivers. So we have a couple more things to see from the systems of the Boeing 787. So I'm gonna show you also, I'm gonna set up the flight management computer. You can see also here we have the flaps control. You can move the flaps up like this or down, retract again, so you can see the position. We have the flaps over here, flaps position 30 degrees fully extended. Also the speed brakes like this, which are secondary flight controls. We have also the landing gear here, extend or retract, display now is down, alternate gear over here, and auto brakes, elected or maximum for landing. You can set the auto brakes like this. So you can see now the engines indication here. We have the N1, which is the low speed starters, have low pressure compressor and turbine of the turbofan to put sensing the left and right engine like this. So you can see low speed starters have low pressure compressor and turbine of the turbofan to the engine exhaust gas temperature per engine. N2, which is the high speed starters, have high pressure compressor and turbine of the turbofan to the engine. And also the limits for takeoff 99.2% green limit, and also the never exceed with red and the amber indication. So you can see N1 and 2 exhaust gas temperature, fuel flow per inch per 1,000 kilograms, thousands of pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So the low speed starters have low pressure compressor and turbine of the turbofan of the engine, and the high speed starters have high pressure compressor and turbine of the turbofan of the engine. Stabilizer trim, rudder trim, flaps also. You can see the gross weight for takeoff over here, 356.9 thousand pounds, the total fuel on board, and the fuel temperature right now. So we have the differential, the cabin pressurization system, but it is usually supplied in most aircraft from the engine's 5th and 9th stage bleeder air, and the bypasser. It pressurizes the cabin when we fly, or depressurizes when we descend, admitted pressurizer. So we have cabin altitude right now 1,400 feet, like our own altitude, barometric altitude right now. When we're going to be flying at maximum altitude like 43,000 feet, the cabin altitude should be 6, 7 or 8,000 feet. Also the rate of climb descent of the aircraft. For pressurization, the differential pressure should be like 7.8 or 8 psi or pounds per inch between the inside cabin and the outside atmosphere. Landing altitude. You can see the outflow valves also for pressurizing and depressurizing the aircraft. you have to pressurize. We have also here, you can see the display in the auto position right now. We can use also the manual. We'll show you later the pressurization panel and the outflow valve. So I'm gonna show you now the flight management computer. I'm gonna set up in the flight management computer all the data we need for flying this aircraft. I'm gonna set up the takeoff gross weight. That includes the empty weight plus the passenger, plus the cargo, plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank, how much we have, 30% in the left wing, 30% in the right wing, and 10% in the center tank. The flight management computer is going to calculate automatically from takeoff, climb, cruises, and approach and landing, the center of gravity. Also, as we fly, we burn fuel, and the center of gravity is shifted, is calculated automatically again. So this affects also the mean aerodynamic core position that I told you where the maximum aerodynamic lift occurs, and also the stall will begin for given angle of attack in flight and an airspeed that is either increase or decrease. So we have also the flight management computer is going to calculate the horizontal trim, stabilizer, the elevator trim position for takeoff, climb, descent, approach, and landing. We can set the auto trim automatically. So we have it 4.25 degrees automatically for takeoff, with 15 degrees of flaps extended. And using this runway, we're gonna use the runway 14 in the Zurich International Airport, Lszh in Switzerland. We're gonna have the runway length and runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. The flight management computer is gonna give us the takeoff speeds, V1, V-rotate, and V2. We're gonna have full takeoff thrust, like 99-100% of the engine's thrust for takeoff, and the V2 is gonna be like 130-140 nautical miles per hour, like 250 kilometers an hour. We're gonna have a pitch altitude of 9 degrees or less for takeoff, and then we're gonna have also the seats. The seats are the salary, departure waypoints and fixes for the initial departure and climb of the aircraft, altitude and airspeed constraints. We're gonna climb to the cruise level at 25, 36, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints. You're gonna see how. So we're gonna have, then we're gonna make a turn. We're gonna descend back to the airport elevation like 76,000 feet above the sea level. We're gonna be aligned with the stars. The solar terminal arrival waypoints and fixes, like two horizontal and vertical indication fixes, and altitude and airspeed constraints for the terminal approach and landing of the aircraft into the airport. We're gonna be aligned also with the ILS localizer, the instrument line system that receives the radio frequency transmitted from the terrestrial antennas of the runways we use for takeoff and for landing. So we have the runway 14 in Lszh in Switzerland. We're going to be aligned with the magnetic north pole heading of 136 degrees for this runway. Also the ILS localizer frequency, we're going to be aligned with the horizontal localizer and the vertical glide slope. Also going to be having 35-30 degrees of flaps extended for approach and landing. An airspeed about 160 170 knots or 270-300 kilometers an hour. And we're going to be having also landing gear extended thrust levers like 60 or 70%, and engine thrust 60-70%, and also pitch is 90 degrees or less. So I'm gonna show you how we're gonna make the flight management computer the flight plan over here. So as before going into flight very quickly, so you can see we have the control quadrant over here. You can set up the flight management computer. So you can see I'm having over here this mouse pad to control. I have my computer. You can see also I'm having the mouse pad here to control the function of the flight management computer and the keyboard and all the setup. So you can see here we can set up the flight management computer like this. So we have over here the index. We have the identity of the aircraft is Boeing 787-900 GNX engines. We can set position, performance, takeoff, approach, announce it, navigation data, anything we need. So we have position at least ZH airport over here in Switzerland, aligned with the initial reference coordinates. We need performance here, takeoff, 0 fuel weight plus fuel on board. We have the gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel freezing, temperature, and center of gravity in flight. So we're gonna set the route first, Lszh over here, departure and arrival, destination and origin over here. So we set 2 times runway 14 over here. So we set the legs over here, departure and arrival. So we can set runway for departure 10, 14, 16, 2832. So we set runway 14 and Zui to Alpha. So we have departures and arrivals again. So we set arrival. We can set 16 approach runway 2834 ILS 14 ILS 16. ILS 28 ILS 34 GLS 14 localizer 28 to localizer 34. So we're gonna say ILS 14 trans Amity over here and trans Negria. So this will give us the legs, the departures. You can see the route is not yet activated. We have the first waypoint 2 nautical miles, the airspeed and the altitude, second, third, fourth. Zui over here 6 nautical miles, climb to the Negria, then descend, approach and landing. So we have the full flight plan. This is displayed with blue. We need to set up the reserve fuel here, zero fuel weight and fuel on board. The cruising altitude 25,300 feet, cost index 100%. So we set 100%, fuel freezing temperature and the center of gravity in flight. We have to press the execute button, so this will activate the flight plan. So we have the first waypoint, second, third, fourth, fifth Zui. We make left turn here in the air, 6 nautical miles, 301 knots, 6000 Alpha. Negria 26 nautical miles from Zui, heading 071, 301 knots, flight level 22,200. Then we make a right turn. We have the Matif 230 heading 320 knots, 11,800. Amity 6 nautical miles from Matif. Zui 9 nautical miles from 7,000 feet, 180 knots. Zurich 701 6 nautical miles from Zui, 186,000 Alpha. TRA 290 10 nautical miles, 185,000 Alpha. CI14 6 nautical miles. Osnem, we make a left turn here to align with the runway, 5 nautical miles from the previous one, 154,000. Runway 14 approach and landing over here. So this is the complete route or flight plan. We use also the flaps for takeoff here, 15 degrees, center of gravity, and V1, we rotate, V2, takeoff speeds over here. So this is a complete flight plan. We need also departure, arrival, alternate, VNAV, progress, hold. We can hold in a waypoint, set fix, and also the navigation radio, tune ILS for instance. So we'll go back here. We need to start the engines in a couple of seconds. You'll see how. So we're gonna set up here again the displays. What they display over here, you can see the navigation that we have. You can see the flight plan, one waypoint by another, the vertical plan over here, and the horizontal profile of the flight. Also, if we look closer, you can see one waypoint by another. You can see the runway here, the taxiway. So this is the runway we are located in the taxiway, and the terrain in front of us with yellow and with amber and green or red colors. So you can see the runway, the taxiway here, just like in the GPS displayed in the terrain around you when you look further away. So this is all the data we need. Also, this map display here, you can see map salary over here. So we set it back here. We need to set up over here the APU to start the engines. So we have the left and the right IDZ, 120 to 200 volts, 400 Hz frequency, 120,000 kilovolts of batteries, primary flight control computers in the auto position, heading reference, IRS over here, flight control surfaces, battery, towing power, FD door, passenger oxygen over here, window heat, rammer turbine over here, and the hydraulic system, left and right engine driving. We turn it off, you will see what they display in default position, the left and right engine driving. We have the electric C1, C2 for a backup, so we set back to the auto. Also you can see we have the recorders here, the cargo and APU fire, the engines, electronic engine control with the auto start system, so you can set the auto start. So this is how to start the engines, electronic engine control. I will show you in a couple of minutes the fuel jet, so we can dump some fuel in flight and make an emergency landing. Select the nozzles and how much to remain. You have also the left and right wing fuel tank, center tank, the crossfeed valve. We can balance the fuel between the left and right wing, and also feed either engine with our powerized tank. We have the wing and engine RDIs over here, or auto. We have the pressurizer from the engines, hydraulic fluid pressurization with the engine RDIs, air conditioning, pressurization and oxygen regulation. In the manual we use the outflow valves climb the descent. So I will show you in a couple of minutes how to make the engine start. Very quickly we set over here the systems display, so you can see what the systems display. We have the hydraulics, APUs running over here, oxygen, liquid cooling. So this is the system, electric 120 200 volts, 400 Hz frequency. The APU is running 120,000 kilovolts, and also the load set and the main batteries 28 volts, and the battery and the APU battery. The hydraulics, we have where hydraulic fluid goes in the aircraft, which systems use it. The side of valves emergency. We have also electric C1 and C2 primary demand. Pressurization 5100 psi, it's left, right and center, and also the quantity of the hydraulics fluid. The fuel on board the aircraft, left and right wing, center tank, the engines left and right are open. The fuel valves open and feed both engines right now. You can see the line, green line from the center of the wings. The crossfeed valve is off, but we turn on, can feed either engine with our pump tank and balance the fuel between the left and right wing tank. We have 11,000, total 73,500 dpg fed from the left wing using the DC motor. Also you can see the minimum fuel temperature down here, below which the fuel will freeze in flight, -37 degrees, and the fuel temperature right now. So we have the air pressurizer from the packs and from the engines. The doors are closed. Over here the cabin can be pressurized. The gear, temperature of the brakes, and the pressure of the tires. Flight controls here, the last thing to see. You can see the deflection of the flight controls like this, the tail horizontal trim stabilizer. So we need to see flight controls like this. All flight controls are correct, as you can see. So go with the rest of the system. Selfies display over here, maintenance, and also circuit breakers. And we have one last thing over here, the checklist over here. So we need to do before start, after start, before takeoff, after takeoff, descent, approach, landing. So go back. Also we have communications. Turn off both engines over here. As you can see, both engines in the off position. Fuel control in the off. Fuel control. Fuel valves in the off position. So you will see what happens. We have the starvation of the fuel from the engines. So we need to use the auto start very quickly over here. Auto start. You can see the amper reconfiguration in the overhead panel from the auto start. So we have pressurizer right now into the engines from the APU. A lot of pressurizer, only the N2 stage. So we can let you can hear the roar of the pressurized air right now. So we can let the fuel control on, both fuel control valves on. So it's gonna take a minute. We're gonna go for takeoff after 1 minute. So we have the auto start on over here, kicking in. So we start the engines. So we have both pressurizer and hydraulic and fuel also. Pressurizer and fuel. So we have a couple of seconds. You're gonna see with green indication here, both engines are running. So we set flaps for takeoff. Parking brakes off. So we need to set also the autopilot here. Engage, disengage the autopilot. You see, autopilot disengage the airspeed. Also we can set the airspeed like this. Also auto throttle left and right like this. Flight director on and off, LNAV and VNAV you can set. So I set also the heading over here, 360 degrees for flying the aircraft, 136. Also we can set the altitude here. One, two, three. And also the vertical speed flight path angle, you can set a descent like this or a climb the other way. So we're gonna set a climb. So we are ready for takeoff. The autopilot is set. Disarm the parking brakes and go. So we advance the thrust levers and align with the runway heading over here. So the runway is open to us for takeoff. So we set our takeoff thrust like this and we go. Align with the rudder pedals. So we pitch up the aircraft slightly. And keep climbing, landing gear up. So we keep climbing over here, as you can see. So we have the air data of the aircraft as we're climbing. And we have 13 more minutes to go back for landing. So you can see we are 2,200, 300 feet above the ground, but 4,000 feet above the sea. The airspeed 175 knots, the stall speed over here. The pitch altitude of the aircraft like 20 degrees. The wind direction and speed, the terrain around you over here. Also you can see how far above the ground we are. We climb with 4,000 feet per minute the engines. Also you can see the flight plan, one waypoint by another. You can see we are like 3,000-4,000 feet above the ground right now. So you can see the outside view also. You can see the airport and the beautiful lakes over here, the Switzerland. So we start the turn on now over here. Make a turn. retract maybe the flaps. I'm gonna having the stall in. If we retract the flaps very fast. So we need to increase the airspeed of the aircraft like this. So now we're gonna be increasing the airspeed very rapidly and also the altitude. So you can see so hope you like the view of the Boeing 787 as we're flying. We're flying here the Switzerland, the Swiss Alps, this beautiful galactic view and the lakes. We have the Germany, my homeland, in front of you, and the France. So we're gonna make an interesting flight. So we need to align again with the flight plan over here. So you can see the view of the Boeing 787 as we're climbing. Also the functions of the aircraft systems. So we need to align here and make the turn. Start turning back to the airport in a couple of minutes. So here we are, the outside view. You can see the Germany, my homeland, the Bayern Munich in front of you. The France, the Switzerland here, the Swiss Alps. Galactic view. So we're gonna make the turn. Over here. So we're gonna start the turn now for going back to the airport. As you can see, use a little bit left rudder over here. So this is Germany over here, as you can see. Very close, overflying it. And the France, the Swiss Alps over here. So we need to make a more steep turn. Also use the right rudder for this turn, a little bit right rudder. So here we are, leveling off. Gonna be having also the frozen vapors, the chemtrails. Here is the chemtrails, the frozen vapors from the aircraft engines, as you can see. So we have the view, beautiful view over here. Of the lakes behind us, the Switzerland and Germany and the France. And we're gonna start the descent back to the airport right now. We need 6 more minutes over here. So we're gonna use idle thrust for the descent and also some speed brakes to increase the descent rate over here. So this is how to increase the descent rate for approach and landing, as you can see. So hope you like again the view of the aircraft as we are descending. We happen to be overflying the airport over here. So you can see the air data as we are flying. Also more idle thrust now. Gonna start the turn now for approach and landing over here. So gonna be a line over here. With the runway shedding. And we need 4 more minutes for approach and landing over here. As you can see, we need to be aligned over here. 3 more minutes. So this is the turn now. Turn for alignment. To save some time over here in the turn. So we almost aligned with the runway here. You can see landing gear down. And flaps also extended. So we are into the runway alignment for landing. Also the outside view for the touchdown, as you can see. So we're going to be touching down like this. Use a little bit more flaps over here. Also a little bit more engine power, and we have also the Lszh localizer here. You can be aligned with the Lszh localizer anytime we need, so we could be aligned. We have a little bit sideway over here, side wing and some wing guards. So we need to use a little bit more flight controls for alignment with the side wing component over here. A little bit less engine. So you can see the side wing is blowing the aircraft in the side. Need to be aligned all the time. Using the flight controls inputs over here, as you can see. So we're going to be having the flare in a couple of seconds. A little bit more thrust over here for the flare. So this is touchdown. Beautiful touchdown. Parking brakes over here aligned with the runway, and thrust, idle thrust, and thrust reverse over here. You can see we have thrust reverse the engines, so we're slowing down. So you can see we just made a very, very beautiful landing over here on the runway, aligned with the runway. You can see all landing gear part, the nose wheel and the landing gear is safe. There is no breakage of any part of the aircraft. Also you can see the thrust reverse. We can use the thrust reverse in the off, so it retracts. So that was Thomas Hatsios using my American Apollo flying the Boeing 787-900. Nice flight. I'll see you next time. Thank you very much for watching. Bye bye.